Hi students, this is Anita Raj, your chemistry mentor. In this session, I am going to give a fast rush up of the formulas involved in the determination of concentration of solutions and also some important new formulas which relates the different concentration terms which would help you to understand the topics and do the problems with much ease and confidence. So let us start this session by seeing the different concentration terms. Okay, so we are going to see the expressions for the concentration of solutions right now. So these are the different concentration terms. The first one is normality. See here, normality. This normality is expressed by the term capital N, and molality, which is expressed by the simple or the term small m, and molarity by capital M. Parts per million by small ppm, mass percentage by the normal simple percentage simple, and mole fraction by the simple capital X. How to make use of these formulas to calculate the concentration of the solutions? Okay, so first let us see the first one, that is molality. See here, molality is always expressed by the simple small m. And how to calculate? What is molality first? It is the number of moles of the solute in 1 kilogram of the solvent. Number of moles of solute in 1 kilogram of the solvent. Okay, so how to calculate number of moles of solute? How will you calculate number of moles of solute? See, normally in this session I have expressed the solute, specifically the weight of the solute with the term capital W with the subscript 2, and molecular mass of the solute by capital M with the subscript 2. And if it is solvent, I have expressed with capital W, mass of the solvent with capital W with the subscript 1, and molecular mass of the solvent with capital M with the subscript 1. Okay, so this is how I have expressed, right? So now number of moles of the solute, N2. How to calculate number of moles of the solute? It is easy to calculate the number of moles of the solute if you know the weight of the solute and the molecular weight of the solute. This is how you should calculate capital W2 divided by molecular weight, that is mass of the solute divided by molecular mass of the solute will give the number of moles of the solute. This is how we should calculate. So number of moles of, see this I have given number of moles of the solute. How to calculate? By using the weight of the solute and molecular mass of the solute. So if you know W2 and M2, it is easy to calculate the number of moles of the solute. Okay, see the formula goes like this: mass, number of moles of the solute in 1 kilogram of the solvent. So the solvent should be expressed in kilograms. If solvent is given in kilograms, you don't want to multiply with 1000. In the case if the mass of the solvent is given in grams, then compulsory that you should multiply the formula with 1000, or if you are not multiplying with 1000, the answer will be wrong. So now here in the final formula I have given W2, that is weight of solute divided by molecular mass of the solute into weight of solvent, and I didn't multiply with 1000 because the solvent weight is given in kilograms, so the unit is also in moles per kilogram. Okay, so always the molality will be given with this unit. We should give this unit, mole per kilogram. So understood students? If the solvent weight is given in grams, definitely you should multiply the formula with 1000. If it is given in kilogram, you don't want to multiply. So this is the formula for molality. Okay, hope you might have understood. Next comes molarity. Next concentration is molarity. How to express molarity? Molarity is expressed by the term capital M. What is molarity? It is the number of moles of solute in 1 liter of the solution. It is the number of moles of the solute in 1 liter of the solution. Okay, see how to calculate number of moles of the solute? I have told this. Weight of the solute divided by molecular mass of the solute will give number of moles of the solute N2. So if the volume of the solution is given in ml, then definitely you should multiply the formula with 1000. If suppose if the volume of the solution is given in liters, then you don't want to multiply. So if it is given in ml, then the formula goes like this: capital M, that is molarity, is equal to now weight of the solute divided by molecular mass of the solute into volume of the solvent solution, volume of the solution. If the volume of the solution is given in ml, then you should multiply with 1000. Understood? So this is the formula for molarity. What is the unit for molarity? It is mole per liter. Okay, since it is number of moles of the solute divided by volume of the solution in liters, for number of moles the unit is mole, and for volume of the solution in liters, per liter. So the unit goes like this: mole per liter. Understood? So these are the two important. So molality we have seen, molarity also we have seen. Then what is normality? This is the next important concentration term. Okay, normality. How to calculate normality? See, normality, it is easy to calculate normality if you know the number of gram equivalent of the solute. What is normality? It is the number of gram equivalent of solute in 1 liter of the solution. What is normality? It is the number of gram equivalent of solute in 1 liter of the solution. What is number of gram equivalent of a solute? How to calculate the number of gram equivalent of a solute? See, gram equivalent of a solute is calculated from the mass of the solute. If you know the mass of the solute, see, if you know the mass of the solute, that is W2, if you know the mass of the solute and also the equivalent weight of the solute, if you know the equivalent weight of the solute, then it is possible to calculate the gram equivalent of the solute. Understood? So how to calculate the number of gram equivalent of the solute? If you know the mass of the solute and also the equivalent weight of the solute, it is possible to calculate the gram equivalent weight of the solute. Okay. How to calculate equivalent weight then? How to calculate the equivalent weight? It is possible to get the equivalent weight by calculating the molecular weight. For example, if suppose sodium hydroxide, if you are taking sodium hydroxide, what is the atomic mass of sodium? So sodium, it is 23. It is 23. Oxygen, it is 16. Atomic weight of oxygen is 16. Hydrogen, it is 1. So altogether, what is it's 0, 4. So see, its molecular weight is 40. How to calculate equivalent weight? Equivalent weight is calculated. See, equivalent weight is calculated from molecular weight divided by since it is as sodium hydroxide, it's a base, so acidity, that is N. Acidity. What is acidity of sodium hydroxide? It's the see, it is having 1 hydrogen atom, so it can afford 1 hydrogen atom. So acidity of sodium hydroxide is 1. So N is equal to 1. So molecular mass, that is 40 divided by 1. So the equivalent weight and molecular mass will be the same. So 40. This is how you should calculate. If it is, for example, if this is sodium hydroxide, if it is sulfuric acid, let us take an acid, H2SO4. Let us take an acid, H2SO4. See how many hydrogen atoms are here? It can afford, this sulfuric acid can afford 2 hydrogen atoms. So in the case of acid, we will be taking the basicity. So N will be equal to 2. So how to calculate the equivalent weight of sulfuric acid? See, the molecular mass of sulfuric acid is 98. Okay. So if you are adding all the atomic masses, then you will be getting 98. The molecular weight will be 98. So 98 divided by the basicity of sulfuric acid. So it can afford 2 hydrogen atoms. So basicity is 2. So it is 49. So the equivalent weight of sulfuric acid is 49. This is how you should calculate the equivalent weight. Okay. So now when you are substituting this equivalent weight, then when you are dividing the mass of the solute with the equivalent weight, it is possible to get the number of gram equivalent weight of the solute. So this is how you should calculate. So now you are just I am giving the values, right? So equivalent weight of the solute. So W2 divided by E into 1000 into V. Okay, since the volume is given in ml, it is given in ml here, see we are multiplying with 1000. If suppose if the volume is not given in ml and if it is given in liters, it is not necessary to multiply with 1000. So students, you should be very careful while reading the problem itself. You should come to a conclusion whether to make use of 1000 or not. If it is given in ml, then it is necessary to make use of 1000. Understood? So what is the unit for this normality? Gram equivalent per decimeter cube or gram equivalent per liter. Okay, gram is for this weight of the solute and it's equivalent, and then this decimeter cube is for the volume. So if it is in you can write liter also. So gram equivalent per liter. So this is the unit for normality. See, normally in physical chemistry, while you are doing the problems, it is very, very important to note the units. So units, it carries separate marks. So units, it's very important. So you should you should be very careful while doing the problems. You should give importance for the unit also. Okay. So next concentration term is parts per million of the solute. Parts per million. See, normally it is represented by the term, what is small ppm, not capital ppm, it is small ppm, parts per million. What is parts per million? It is the weight of the solute in 10⁻⁶ grams of the solution, or weight of the solute in 1 million of the solution. See, normally we will make use of this ppm to express the concentration of the substances if they are present in trace quantity or very little quantity. See, normally the pollutants that are present in air and water will be expressed in terms of ppm. Okay, the pollutants, the concentration of pollutants, if you want to express, then that will be expressed in terms of ppm, right? So what is ppm? It is the weight of the solute present in 10⁶ grams of the solution or 1 million grams of the solution. So how will you calculate? Say weight of the solute, say W2, and weight of the solution we will be expressing with the term capital W into 10⁶. So this is the formula, W2 by weight of this, W2 is the weight of the solute and this is weight of the solution into 10⁶ will give the concentration of the substance present in the solution with ppm. Okay, and next one is mass percentage. What is mass percentage? See, mass percentage is it will be normally expressed in by with the simple this percentage symbol. Understood? So how will you calculate the mass percentage? Mass percentage is calculated by, see, if you know the mass of the solute in the solution and the total mass of the solution, it is possible to calculate the mass percentage. So mass percentage is the mass of the solute in solution in total mass of the solution. So mass of the solute divided by total mass of the solution into 100 will give mass percentage. So what is normally we express the mass of the solute by capital W2, is it not? So capital W2 and then volume, this is weight of the solution into 100 will give the mass percentage. So mass percentage is the mass of the solute in total mass of the solution into 100 will give the mass percentage. Okay, so this is, and this is also very important formula, mass percentage. You'll be getting many types of problems coming under this. Okay, and next comes mole fraction. What is mole fraction? How will you express this? How it is expressed? See, capital X. If you want to calculate for solute, then solute, you will be writing the solute as a subscript. If it is a solvent, then here. How to calculate the mole fraction of a solute? See, mole fraction of a solute is calculated from the number of moles of the solute and number of moles of the solution. Okay, see how to calculate the number of moles of the solute. See this, you know, number of moles of the solute we have seen in the previous expressions, right? How to calculate the number of moles of the solute. See, if it is N2, see here I have expressed the solute with small n, and capital N is for number of moles of the solvent. Okay, so small n is for solute, it's for solute, and capital N is for solution. Okay, sorry, solvent. Okay, so this is how I have expressed here in this formula. So how to calculate the number of moles of the solute? See, this is how number of moles of the solute can be calculated by this formula, number of moles of the weight of the solute divided by molecular mass of the solute. See, if you know the weight of the solute and molecular mass of the solute, it is possible to calculate the number of moles of the solute. Likewise, if you want to calculate the number of moles of the solvent, then you should know the weight of the solvent and also the molecular mass of the solvent. So, if you know the weight of the solvent and the molecular mass of the solvent, it is possible to calculate the number of moles of the solvent. So, by using this formula, we should calculate the number of moles of solute and the number of moles of the solution solvent. And how to calculate the number of moles of the solution? Number of moles of solution is calculated by summing up the number of moles of the solute and the number of moles of the solvent. This will give the number of moles of solution. Understood? Solute plus solvent will give solution. Solute plus solvent will give solution. So, number of moles of solute plus number of moles of solvent will give the number of moles of solution. So, this is the formula for solute. If you want to calculate the mole fraction for the solvent, in the numerator you should write the number of moles of solvent divided by number of moles of the solution. So, how to calculate the number of moles of solvent? So, this is the formula. Number of moles of the solvent is equal to weight of the solvent divided by molecular weight of the solvent. From this formula, it is possible to calculate the number of moles of the solvent. Then you should substitute the value here, and here obviously after calculating the number of moles of solute, then we should sum up the number of moles of solute and solvent to get the number of moles of solution, and you make use of the value here. See, for your information, that's another important thing to be noted. See, if the sum of the mole fraction of all the components of a solution is equal to 1. What do you mean by all the components of the solution? What could be the components of a solution? Component of a solution are solute and solvent, right? Solute and solvent. So, solute and solvent are the components of solution. So, the mole fraction of a solute and mole fraction of the solvent will be equal to 1. So, sum of this is a very important formula. Understood? Okay, so we'll move on. So I hope you might have understood all these formulas and expressions, how to arrive at the concentrations. Okay, so here we are going to see the important relations among the concentration formulas. Already we have seen the concentration formulas like molality, molarity, mole fraction, normality, mass percentage, right? Now we are going to see some important relationship among these concentration formulas. See, actually we can make use of these concentration formulas, like relations among the concentration formulas, to do the problems in a minute. Okay, within a minute it is possible to complete the problems. Okay, you don't want to go in depth, so directly you can make use of some certain values and find out the answer. For example, in some of the problems they would have given the mole fraction of the solute and the solvent alone. So, if the mole fraction of the solute and the solvent alone, and if they are asking you to calculate the molality, you can make use of this formula. So, if you know if the mole fraction of the solute is given and the mole fraction of the solvent is given, it is possible to calculate the molality of a solution using this formula directly. You don't want to go in search of other things, right? Directly you can make use of this formula. And what is capital M1? It is the molecular weight of the solvent, right? So, molecular weight of the solvent is easy to calculate, because it definitely in the problem they would have given the if the solvent name is given, if the name is given, if it is acid or whatever it is, acetone or whatever it is. So, you can find out the molecular mass by summing up the atomic weight of all the components present in that particular compound, right? So, it is possible. So it's easy to make use of this formula, and you can find out the answer within a minute. Okay, and the next formula is normality. How to relate normality and molarity. See, normality, if you want to calculate normality, you are in need of number of gram equivalent weight of the solute and then volume of the solution, etc., etc. Is it not? So it will take much time to complete that problem. So if you want to finish, if the molarity of the molarity is given in the problem, then it is easy to calculate the normality. For example, if the molarity of the solution is 0.01, then it is possible to calculate the number of normality within a minute if you know the acidity or basicity. For example, if it in the problem, if it is given as a 0.01 molar H2SO4, if it is given like this, calculate the normality of 0.01 molar sulfuric acid, it is easy to calculate the normality within a minute, because you know that this sulfuric acid can afford 2 hydrogen atoms. So the basicity of the sulfuric acid is 2. So if you and you know the molarity, so how to calculate normality? 0.01 into n, is it not? N is 2. So it is easy, within a minute it is possible to calculate 0.02 n. So this is the answer. Understood? So normality and molarity, this is how this formula is useful, right? So normality and molarity, how to relate. Okay, so it's another important formula. And next formula is another important formula, that is how this formula relates normality and mass percentage. Normality and mass percentage. See, in some of the problems they would have given like this, 90% sulfuric acid by weight. By weight, like this they would have given. Okay, by weight, like this they would have given, and the density of this solution they would have given. So it is possible to calculate immediately. So in this formula they have given capital N, that is normality, is equal to mass percentage into density of solution into 10 divided by equivalent weight. Mass percentage into density of solution into 10 by equivalent weight. So you can make use of mass percentage 90 directly, and density they would have given. So and then into 10, then what is the equivalent weight of sulfuric acid? So equivalent weight of sulfuric acid can be easily found out by knowing the molecular mass. Molecular mass of sulfuric acid is calculated from its atomic weight as 98 divided by its basicity. Basicity is 2, so 49. So it's easy. So easy to calculate the equivalent weight of sulfuric acid. So by substituting the values directly within a minute, it is possible to calculate normality. So it is a shortcut method, right? So it's very easy to make use of this formula also. And next formula is how relationship between molarity and mass percentage. See, this is the formula. This formula goes like this: capital M is equal to mass percentage into density of solution into 10 divided by M2. What is M2? It is the molecular mass of the solute. Okay, it is the molecular mass of the solute. Okay, so molecular mass of the solute. So if you know it is possible to calculate the molecular mass of the solute. In the problem itself they would have given this is the solution. For example, if it is HCl solution, then you should find out the molecular mass of HCl. Okay, so then you should substitute directly. You can make use of the mass percentage and density of the solution they would have given. So it is easy to calculate the molarity of the solution within a minute. So these are all the very important formulas by which you can easily determine the molality, normality and molarity from the values given, whatever it is given.